Um, Bonsoir, je suis désolé, but my French is really not good enough to do this in French. I don't know, I love being here on holidays, but I spend all the time eating the good food and never learning the language. I don't know. So I was told I have about 20 minutes to tell you everything about the IoT and business process management. And I was also told that half of the people here more coming from a business point of view and the other half more from an IT point of view. So I will try to also accept this challenge in English. So let's see how this goes. Plus, this is kind of like the last block in the afternoon, so I have to try to keep you awake. So I'm sure you've seen these numbers about the Internet of Things, right? I actually think there is a pub somewhere in San Francisco where the marketing manager of Cisco, of Gartner, and of IDC meet about once a month, and then one of them comes out, goes home, and thinks, man, I have to come up with bigger numbers about the Internet of Things, right? So just looking at this, I mean, kind of like the standards, 50 billion connected devices by 2020, 7.1 trillion IoT solutions revenue predicted by IDC. So I think one question is, where do all these numbers actually come from, right? And I think it has become a little bit of a self-fulfilling prophecy based on the fact that a number of things are actually coming together, okay? And I think one of them is actually that we can really now see how cost for communication in the next 10 years will be lowered to a level where pretty much my kids' toys will be connected to the IoT, right? For better or worse. And I think this is really fueling this discussion about the IoT. But the interesting question really is, where do we find business models for the IoT? Why is a big company like Bosch actually so interested in the Internet of Things? Okay, just looking at our products, about half of our revenue comes from automotive components. And alone in this space, we see a lot of interesting things happening, right? 360-degree parking, autonomous driving, car-to-car, car-to-X, etc. Okay, all of these things have a lot to do with the Internet of Things. There are many other examples. The Internet of Things connected refrigerator, I still don't believe. When I started with Bosch, I also did not believe the Internet of Things connected tightening tool that you see on this slide, because I always thought when I'm at home and I do some DIY, right? So I don't know, I do something in the garden or so, I have enough people telling me how to do my work, and I have my family telling me how to do this at home. I don't want my power tool even to tell me how to do this better, right? Turns out this is actually a very interesting industrial case, and I'll talk about this in a minute. What we see is that this is going to change in the future, because the IoT is all about connected products. Okay, so being able to actually stay in touch with your customer after the product has been delivered to the customer, okay, which has a fundamental impact on the features of the product, but also how, as a manufacturer, you really look at asset lifecycle management. It also means that as a manufacturer, we really have to become more so as an operator, okay? Because you need to operate these things out there in the field. The benefit is that you get constant product feedback, which helps you to enhance your products. You get product feedback, which means you can improve your customer services, and you might even be able to sell additional digital services. And today specifically, of course, is about integration between things and processes. Okay, so that's one thing that we see that really has to grow together, because if we start rolling out connected products, okay, we see that this is going to have a huge impact on processes, and that has to be managed efficiently. One of the things that we've learned is it is actually pretty pointless to just connect your products to the internet. Nothing's going to happen. What you really need to build new business models is to actually connect your products to the internet and then build services on top. Okay, so it's really the combination of connectivity and services that creates new business models. So one example that I always like to use is the Bosch eCall service, which basically is a sensor embedded in a car and connectivity to the airbag that basically gives me information whether there was an accident, and that's then routed to a call center where we can pick this up, right? And we have a process in the call center that basically helps evaluating the severeness of the problem, potentially involving a call center agent, making sure actually that we find out the language of the car driver and make sure that the call center agent answers in the right language. Or if it's really severe, we automatically direct an emergency service to the suspected site of the accident. Okay, so this is actually a pretty big service for just one sensor and a small piece of connectivity, but it has huge value add. So at the moment, for example, Daimler is using this as a differentiation, and we believe it will become part of the EU legislation to make this available for all cars in the EU. So what we found out is really you need to support 4 perspectives for this, right? So there's the perspective of the thing. Well, actually, nobody talks about things. People talk about devices, about assets, right? But it happens to be called Internet of Things. Then, of course, the enterprise function for the service, which typically is process-oriented, right? Then, of course, the interface of the user to the asset and to the processes provided by the enterprise. And again, the integration with the partner. And as much as we talk about, latest technology, MQTT, what have you, in the IoT, I saw in your presentation earlier on, you had the dirty word on it, EDI, electronic data interchange. It's not going to go away, right? So it's going to be part of this whole formula, right? So these things really need to grow together in order to support this ecosystem. And I think this slide speaks for itself. So let me do the next 2-3 slides. Otherwise, we have no chance halfway being on time. Couple of examples. So this is actually in the area of e-mobility. Not there yet, but of huge strategic importance. This is a joint venture between Daimler, BMW, Siemens, and most of the major European utilities to set up a roaming service for electric vehicles. Okay, so that if I drive my electric vehicle from Berlin, where I live, to Hamburg, where I don't maybe have a contract with the local utility, I can still charge up my car. Okay, and then the Hamburg utility deals with the Berlin utility to make sure that it gets on a single bill. Okay, so sounds like a process to me. Next example, a little bit more out there in the area of manufacturing. Okay, so this is about the integration of handheld industrial tools, right? Like this little thing you see there in the corner. And I said early on, I didn't believe in IoT-enabled power tools. This is actually a professional tool. Cost is about 8,000 euro. It has an onboard computer that can control a multi-phase tightening process. Imagine an aircraft that has 400,000 security-relevant tightenings, right? And if only one of them in the wrong place isn't tightened properly, something happens like with large airline 3 years ago where the window in the cockpit goes off and 3 people die because they fly out. Okay? So you want to make sure that the right tightening program for the right connection is always there on the right place and the right time, and that you can also create a quality profile of each of these tightenings. Okay, so this we actually want to advance to a level where we can actually integrate this with a complete virtual model of the tools, the factory environment, and the products we're working on to automatically reconcile the 3D model in the PLM with the actual task, okay, to make sure that we have the right work instruction from the PLM work downloaded onto the tool in time, okay, and then create a quality lot that can be written back to the 3D PLM model to really make sure that all of these 400,000 relevant connections are recorded, okay. So I think that's another really good case for using IoT in an industrial environment. 4 key challenges, right? So first of all, you need to integrate these things. Second of all, you need to manage the data that either needs to be deployed on the things or that comes back from the things, like the quality lot I was mentioning earlier on. You need to be able to manage the events that come from the things. Okay, so for example, in the solution I just mentioned, certain tools can only be used in a certain area. So I want to have a geofence around the particular aircraft, for example, I'm working on, and if I leave the geofence, an alarm needs to be raised, and this alarm needs to be processed, and that's actually the fourth challenge. Okay, so how does the process look like that reacts to this event? Okay, should I switch off the tool? Should I send a text message to the supervisor, etc., etc.? Okay, and this is pretty much what we do. A little bit of self-advertisement is okay, right? This is what we do at Bosch Software Innovation. So we have products to help you addressing all of these challenges on the software level. How do we actually get there? Okay, so what we've seen is that you somehow need to be able to get from a theoretical model down to an actual digital model. One key question is, how fine-grained should this digital model actually be? Okay. Then the next question is, what inception points do you actually have to create this digital model, right? So this simplistic example, soccer. How do you use a sensor to find out if a goal was scored, right? Do you use a noise sensor, right? If, for example, you know, Paris plays at home in Paris and the noise is really positive, that means that Paris scored a goal? Or how do you reconstruct this event to build up this model? And then how can you actually then add processes to this model to actually implement the logic that you want to implement? To make it a bit more interesting for you, I'll do 4 more slides in one go. So what we discovered is that there's a pattern that we call process to device and device to process that needs to be supported by this solution. Okay, so think of a solution that supports security for malls and airports and things like this. Okay, so you have different sensors, and the first sensor tells you there was a suspicious movement. Okay, so this triggers a process in the backend which tells an operator to zoom a camera to the point where the noise was and look into it. Okay, no problem here. So next thing that happens is the noise gets really loud. So the system gets nervous and says, okay, forget about the operator, send a security guard to the mall where this is happening because this is urgent. Okay, so the poor security guys, right, you know these guys, big torch, he goes into the building and tries to find out what's happening. Next thing, actually you have another sensor that tells you, no, there's a fire going on. Okay, so what do you actually do? You need to abort the previous process. You need to get the security guard out of the building as soon as possible and start a different process that actually alerts the fire brigades. Okay, so key question here is, how do you correlate all of these different events and how do you map them to processes? And how does this map to your digital model? And are we still talking about traditional process management here, or are we now in the realms of adaptive case management, as I would argue in this case? So in addition to the processes that actually support the service provided by the IT solution, you also have to look at this from an asset lifecycle management point of view, because these processes also will change in an IT world. Okay, so think of the sales process, which needs to incorporate things like commissioning. So the first time somebody buys an IT-enabled device and switches the device on at home, okay, there is typically a registration process now involved that you need to support. Okay, and then you operate. Okay, so that means you get a lot of data from your devices. But what do you actually do? Is your support organization, are your processes in your support organization prepared to actually act on this data? Okay, so in our experience, this can mean a big change process, for example, in your support organization, up to like 3-4 years before you can really fully leverage these new capabilities in your organization. That's not an easy task. I've been working together with some colleagues and actually documenting this. We've written a book called Enterprise BPM, which now is available in English. Anybody interested in doing a French translation, please send me an email. And originally, so we've set up something which I guess is a little bit similar to what you're doing here. We call this the Enterprise BPM Alliance, which basically is developing a methodology, a very hands-on methodology that tries to bridge the gap between what we call the gap between Six Sigma and XPDL. Okay, so try to go from a high-level strategic thinking about processes to the actual implementation. Okay, and in the past, this methodology has been more used in banking, insurance, etc. But we're now also more and more applying this to these IoT type of cases. And that's really all I wanted to share with you today. Thank you.
Donc, juste deux mots de conclusion. Vous avez créé une méthode et un livre qui permettent d'aller de la vision un peu stratégique du processus, Lean Six Sigma, à son implémentation telle qu'on l'a vu aujourd'hui. Donc, s'il y a un volontaire parmi vous pour traduire ce livre, il faut écrire un mail à Alder. Maintenant, nous allons passer. The deal is that you translate that one in German.
Okay, it's a deal. They call it quid pro quo, right?